Hello Year 5 and welcome back to our topic of space. Today's lesson is going to be all about days, years and seasons as shown at the top of the screen. So can I please ask you to get a piece of paper and a pen if you're handwriting your notes and write down the title, which is days, years and seasons, and also today's date. And obviously if you're typing your notes, then make sure you give yourself a new subheading and also write down the date so it's easy to find these notes at a later time. You can pause the video while you write the title and date to give yourself some time. Brilliant. Now that you've written down the title and the date, it's time for a slight recap on what we've been covering so far. So let's have a look. So the solar system is made up of various different celestial objects. Now have a think. Some of them are in the picture on the right hand side. We obviously have our sun. It's at the centre of our solar system. It's what all the planets orbit around. We have the planets themselves, as we well know. We've also got the moons. Different planets have a different number of moons. Some planets don't have any moons. We obviously have one, okay, but various other planets have more than one. We also have the asteroids, and we also have comets. Okay, these are all the different celestial objects that make up our solar system. So how do these objects all interact? Well, interestingly, as we said, the sun is at the centre of our solar system. It is a star. It's a massive ball of hot glowing gas. Because of its size, it has the strongest gravitational field in our solar system, okay, which therefore causes all the other celestial bodies that we've just mentioned to orbit around it. Those of you might be wondering if you need to write this down, and at the moment you don't, because we've already got notes on this information. I will let you know exactly when and what I want you to write down during the video. So just keep watching and keep listening. Okay, we're going to be looking at days and years now. So on the left hand side we can see there's a question and it says, how long does it take the Earth to spin once on its axis? Okay. How do the Earth and Sun move in relation to each other? Click play to find out. Let's click play and see what happens. So we can see now that the Earth rotates about its axis, which is tilted at an angle of 23.5 degrees. One complete rotation about the Earth's axis takes 24 hours. So the Earth is on its axis at 23.5 degrees and it takes 24 hours to completely rotate once, and that is obviously 1 day. Now what I'd like you to do is to pause the video now and write down the bits of information that you can see on the left hand side in the orange box. Get both those sentences written down now please. Now you can see on your screens, at any time, only half the Earth faces the sun and is in daylight. So from the diagram, you can see that on the right-hand side is where the sunlight is coming from. Only that half of the world or the Earth is in that sunlight and therefore it is daylight. The other half that faces away from the sun at that time is consequently in darkness, and that is obviously what nighttime is. Again, can I please ask you to pause the video here and note down both those two sentences on the left hand side again, highlighted by my cursor right now. So both those sentences written down in your notes, please. And finally, obviously, as the Earth rotates on its axis each day, it is also orbiting the sun at the same time. Now, as we know, it rotates fully once every 24 hours, but it completely orbits the sun every 365.25 days. Now you might be thinking, why is it 0.25? I thought a year was 365 days. Well, I'm going to give you 10 seconds to have a little think as to why that might be. Your 10 seconds is up, and those of you who remembered that we also have something called a leap year every 4 years are bang on the money. That is the reason why it's 365.25. That 0.25 multiplied by 4 gives us 1 extra day, which happens once every 4 years. Again, I would ask you now, please, to write down in your notes the 2 sentences that are on the left-hand side of your page right now in the orange box, like before. Okay, moving on, we're going to be looking at time zones now. As you can see at the top of the screen, it is 4 a.m. in London. It's obviously not 4 a.m. right now when you're doing this lesson, because that would be silly. But for this example, we'll take it as 4 a.m. in London. What is the time in the rest of the world? Well, in different parts around the world, depending on where we are in relation to those, okay, we are going to see the following. So Casablanca is plus 1 hour from London. Therefore, it is going to be 5 a.m. Pretoria in South Africa is plus 2 hours. So if it's 4 a.m. in London, it's going to be 6 a.m. in Pretoria. Antananarivo, pardon my pronunciation, is in Madagascar, and that is 3 hours ahead, so it's going to be 7 a.m. And finally, we have the Philippines over on the far right-hand side of the world. It is 8 hours ahead, which means it is midday. Next up, we are going to be looking at the path of the sun in the sky, and I would like you at the end of these 3 different animations to draw out the diagram that you are going to see. So, first of all, we have the path of the sun during the summer. As you can see, the sun is very high in the sky, and it tends to be high in the east, in the south, and also in the west. Next up, we have the path of the sun in both the spring and the autumn. Notice that the sun is a lot lower in the sky, and this is one of the reasons why the days are shorter in the autumn and spring than they are in the summer. Finally, we have the animation of the path of the sun in the sky during the winter. As you'll see, the sun is a lot lower, and this is the reason why in the depths of winter the days are very dark in the morning, the daylight is very short, and then it gets dark very early in the evening. I suggest you now pause the video and draw out that diagram that you see in front of you, please. Okay, so we are now going to be looking at hemispheres. As I'm sure you already know, the Earth is divided into 2 hemispheres, and these are separated by the equator. We have the northern hemisphere, which is in the north of the equator, which is where England is based, and we also have the southern hemisphere, which is everything below the equator, which is where countries like South Africa and Madagascar are. Very quickly, I would like you to do a very brief sketch of the Earth divided into its hemispheres, but also remember, try and make it so your Earth is slightly tilted as it realistically would be. Don't forget to also mark on the equator. So the next question for us to answer is, why do the hemispheres have different seasons at different times of the year? Well, we are going to find out here. So you are going to need to write some notes down, but again, just wait for me to tell you exactly what you need to write and when. As you can see from this slide, watch the orbit of the Earth around the sun over the course of a year to see how the tilt of the Earth causes the seasons. So, stage 1, we have the Earth is tilted on its axis at 23.5 degrees. At this point of the year, the southern hemisphere is tilted towards the sun. So right now, in this picture, it is winter in the UK. The Earth moves a quarter of the way around the sun. At this point, neither hemisphere is tilted more towards the sun, so therefore it is spring in the UK. The Earth travels another 90 degrees around the sun, so that it is on the opposite side to where it started. Now the northern hemisphere is tilted towards the sun, which is why it is now summer in the UK. You'll probably be able to guess that for stage 4, the Earth moves another 90 degrees around the sun. Now neither hemisphere is tilted towards the sun more than the other. Can you guess what season it is in the UK? For stage 5, the Earth returns to its original position. The year is over and it is winter again in the UK. So you can imagine two identical sun rays hitting the Earth. Do the rays strike the same amount of the Earth's surface? What effect do you think this will have on how the two rays heat the ground? I'm going to give you a little bit of time to have a think about that before I explain what it means. Well, the answer is, as you can see, the northern hemisphere is tilted away from the sun. Now, obviously, it still receives light from the sun, but because it is tilted away, that energy from the sun is spread out over a greater area, which means it doesn't heat up as much. Compare that to the southern hemisphere, as shown below, and you'll see that the energy and the light from the sun is directed in a more concentrated area. That means the more energy of the sun that's visible on that part of the planet, the greater the heat, and therefore it is summer. And finally, some virtual questions for us to see if we can answer. So, what is the season? As you can see, the northern hemisphere is tilted away from the sun, so therefore it is going to be winter. The southern hemisphere is tilted towards the sun, so therefore it is summer. Let's see if we can solve this. We are correct. Fantastic. Well done if you thought that along with me. Moving on, the sun is now coming from the opposite side of the Earth. So let's have a look. The northern hemisphere, pictured above here where my cursor is tilted towards the sun. Therefore, the northern hemisphere, it's going to be summer. The southern hemisphere, as you can see, is tilted away from the sun. So because it's tilted away, it's going to be winter. Let's solve. We are correct. Fantastic if you thought the same. It is now worksheet time. So you are going to have some worksheets that you need to complete. These are going to be able to be accessed on Microsoft Teams. So head back to Microsoft Teams, check out your instructions for today's lesson. There will be links to all the worksheets there, so you can print them off and complete them. Or if you can't print because you don't have a printer or don't have access to a printer, you can simply write the answers on a piece of paper. Head over to the links to the worksheets. They've been posted in your lesson instructions. That's it from me. Thank you very much again. I hope you enjoyed this lesson on days, nights, and seasons, and I look forward to seeing you next lesson. Thank you very much.